Hello, Sahil.
Hi, sir.
Everything good?
All great, sir.
All right. Revised everything?
Not much, sir.
Not all right. I hope you remember at least what it is in the last
Yeah,
class,
yeah.
right?
Yeah, sir.
All right. So if a function is continuous, then limit at that value must be equals to function value at that point, right? This thing. Yes or no, both? Zayed, Sahil,
Yes, sir.
both?
Remember, sir.
Yes.
All right. So if you face any questions regarding continuity, you have to find this value f of a and limit of f of x extending to a. If both are equal, then everything is good. Not, then not continuous. So let's jump into a question. Write down. Show that the function f of x given by f of x equals to sin x upon x plus cos x, and x is not equal to 0, and 2 when x equals to 0 is continuous. At x equals to 0. Right, note down this question. Don't try to solve this. Done?
Yes.
Sahel?
Done, sir.
All right. So they are asking to find continuity at which point x equals to 0. That means in this equation we have a equals to 0. Right? This is clear, both of you?
Yes.
So what you have to find f of a first. That means f of 0. So can anybody tell me what is f of 0 here? What is f of 0?
2.
2. Absolutely right. Why so? Because in the function they have mentioned when x is 0, function's value is 2. When x is not 0, function's value is this. This is clear, Zayed?
Yes.
So this is 2. Now we have to find limit value. So limit x tending to 0, f of x. Yes or no?
Yes.
So what will be the value of f of x here? What should I put f of x?
So 0.
Not 0. What is the function here? What function should I place? Look at the function given.
So sin x by x plus cos.
Absolutely. And why not 2? Zed, why not 2 here? Because 2 is also the function. See, we have limit x tending to 0, right? And whenever we use limits, x is never equals to 0. X is almost 0. So the value of the function is 2 when x is equals to 0, right? Otherwise, we have to assume this function.
Yes.
All right. Sahel, this is clear?
Yes, sir.
All right. So now evaluating this limit is very simple. We can break down x is 0 sin upon x plus limit x tending to 0 cos x, right?
Yes.
So this is standard limits. I've given you the formulas. So limit x tending to 0 sin x upon x is
1.
1. And you can direct substitution, use direct substitution here. Cos 0 is
1.
1. So the answer here is 2. So we have got limit x tending to 0 f of x equals to f of 0. So function is
30.
continuous. Very simple. Both of you, is this thing clear?
Yes.
Sahel?
Yes, sir. Clear.
All right. So please try to solve this question again without looking at the screen. All right. Let me scroll this up. See if you can solve it. All right.
Yes.
I'll give you a few minutes. All right, Zaid. Sahel solved it. Sahel done. Zaid, please note down this question. All right. Let's see. Zaid, in this type of questions, you cannot find limit directly, right? You have to find LHL and RHL. Why so? They have broken down this function into two parts or three parts. X is less than half, X is more than half, and X is equals to half, right? So first step always to find f of half, right?
Yes.
Right. Sahel, you there?
Yes, sir.
All right. So in this question, they are asking you to find continuity of the function at x equals to half. But what is the difference between this question and previous question? In this question, function is broken down into three parts. where x is less than half, x is more than half, and x is equals to half. So you cannot find limit also directly. You have to find LHL and RHL, right? Sahel?
You can explain again because I wasn't there. Like your voice stuck after you explained the first question.
All right, all right. Let me explain again. No worries. See, in this question, or the previous question you were asking.
The previous question was over, right?
Yes, that was over.
Yeah. This question.
So in this question, what they have done, they have broken down f of x into three parts, right? Three domains. One is where x is less than half, where x is more than half, and x is equals to half, right? Sahel?
Yes, sir.
All right. All right, Zaid, we'll look into this. All right. So what you have to do here, you have to find LHL.
Can I ask?
Yes.
So if LHL is not equal to RHL, then we don't have to find f of a.
Right. You
Yes.
don't have to find. All right. So Sahel, first step always to find f of half, right? They have directly given you f of half, so no such hard work this is. But now to find limit, you have to find LHL and RHL, right, Sahel? Because of this domain, x is more than half, x is less than half. There are two different functions, right? Yes or no?
Yes, sir.
So what is LHL? LHL we already know, limit x tending to, we have to find continuity at half. So we will write half minus and f of x. This thing is clear?
Yes.
All right, Sahel.
Yes, sir.
So what is f of x here?
So half plus x. Sorry, half minus x.
Minus x. So we can replace the value limit half minus x, x tending to half minus. Now I've told you always substitute the value. X is half minus h and h tending to 0. So we can rewrite the limit as limit h tending to 0 half minus h. Now we can put h equals to 0 directly. So this will be 0. Yes or no, both of you?
Yes.
Yes, sir.
All right. So same way we can find RHL. Limit x tending to half plus f of x, and f of x here will be 3 by 2 minus x, right? Look at the question. When x is more than half, we have to assume this as the function. Yes or no, both of you?
Yes.
Yes, sir.
All right. So again, putting x equals to half plus h tending to 0. All right, Zaid, no worries. So this is limit h tending to 0, 3 by 2 minus half plus h. Again, put the value of h directly. So the answer is 1 here. So we can see LHL is not equals to RHL. So the function is discontinuous at x equals to half. This thing is clear, everyone?
Yes, sir.
All right, so please note it down. This way you have to solve questions. Not very tough. Note it down.
Done, sir.
All right. Now next question is for you. Both of you try to solve this. Discuss the continuity of the function. Given by f of x equals to 2 minus x, x is less than 2, 2 plus x when x is more than equals to 2, at x equals to 2. A very simple question. Hello, Emma.
Hello, sir.
Everything good?
Yes, sir.
Again, you are late today.
Sorry, sir.
All right, we have solved few questions on continuity. So in the last class, I told you for a function to be continuous, you have to find limit at that value and function's value, right?
Yes, sir.
So let me explain this question. In this question, they are asking, discuss the continuity of the function. If at x equals to half, and the function is given as half minus x, and 0 is less than equals to x is less than half. The function is 1 at x equals to half. 3 by 2 minus x when x is more than half but less than 1. All right. So first point, always to find the value of the function at that point, right? We are checking the continuity at half. So we have to find f of half, right? F of a, right, Aman?
Yes, sir.
So f of half here is 1. They have given you x when x is half. Function value is 1, right?
Yes.
All right. Now you have to find limit, right? You have to find limit extending to half f of x. Now to find this limit, the function is broken down into 2 parts. One where x is less than half, one where is more than half. So first we have to find LHL, limit f of x extending to half minus, right? LHL is half minus. And when x is less than half, we have to assume this as the function, because when x is less than half, you have to use this function, right, Aman?
Yes.
All right. So I just replace the value of the function, half minus x and half minus. So now we know how to find limit x is half minus h tending to 0. Just substitute this value. We got LHL equals to 0. Same way, we are finding RHL, limit h tending to half plus 3 by 2 minus x is half plus h tending to 0. Same way we found RHL is 1. So if LHL is not equals to RHL, then we can say limit does not exist. So function is discontinuous at x equals to half. Is this thing clear?
Yes, sir. It's clear.
All right. All right, Zayed. No worries. So Aman, try to solve this question. Again, very simple question.
Okay, sir.
All right. It's all right. Tell me when you are to solve this. solved it? Aman, Sahel?
Yes, sir.
All right. So again, very simple. First, we have to find f of 2. And what is f of 2 here? Who can tell me what is f of 2?
So 2 plus x.
2 plus x, right? Because they have mentioned when x is greater than or equals to 2, you have to assume this as the function. So 2 plus 2, this is 4. Now LHL, limit extending to 2 minus f of x. So Aman, what function to assume here? Or is
Sir, 2 minus x.
2 minus x. So x we replace with 2 minus h tending to 0. So finally, what we have, limit h tending to 0, 2 minus h. Now you can use direct substitution, putting h equals to 0. So 2 minus 2 is 0. All right. This thing is clear.
Yes, sir.
Now RHL, limit extending to 2 plus f of x. Sahel, what will be f of x here?
2 minus x.
Not 2 minus x.
2 plus, sorry.
2
my
plus
bad.
x.
Plus x, right.
So x we can replace with 2 plus h tending to 0. So limit x tending to h tending to 0, 2 plus h, direct substitution, this is 4. So we can clearly see that LHL is not equals to RHL. So function is discontinuous. Everyone is clear about this?
Yes.
Yes, sir.
All right. Next question. Show that f of x equals to 5x minus 4 when 0 is less than x is less than 1, and 4x cubed minus 3x when 1 is less than x is continuous at x equals to 1. All right, try to solve this. I'll give you a few minutes. All right, Sahel. Aman, have you solved this?
Yes, sir.
Okay. So I don't need to solve this. We can move forward.
Yes, sir.
All right. Next question. Show that the function f of x equals to 2x minus mod x is continuous at x equals to 0. Write down the question. I'll give you a few hints. All right. See, whenever you see modulus functions, always the trick is to always open the function. So we have mod x. Mod x is opened as x when x is positive, minus x when x is negative. All right. You can use equality sign anywhere. Doesn't matter. All right.
Yes.
So you can rewrite this f of x as 2x minus x when x is positive, right? We can replace mod x as x, and 2x minus x when x is less than 0. This thing is clear, all of you?
Yes.
Sahel, Aman.
Yes,
Yes,
sir.
sir.
All right. So now this function is your main function. You can find the continuity of this function very easily. Solve it. All right, Sahel. Aman, done?
Yes, sir.
All right. So no need for me to solve this. Yes or no, everyone?
Not a need, sir.
All right. So this thing you must remember, whenever you see modulus function, just open the brackets. All right. So if you face modulus function like this, x minus 5 modulus, how to open this? X minus 5, you will write this as x minus 5 when x minus 5 is positive, and this is minus of x minus 5 when x minus 5 is negative. You can simplify this further. X is more than 5, x is less than 5. This thing is clear,
Yes.
right? So this whole masala will be positive when this andar ka masala is positive. Masala will be negative when andar ka masala is negative. All right. Sahel, Aman, this is clear?
Sir, can you repeat it again? I don't understand.
See, what I mean by this, you can replace this value with this when this value written inside the modulus function is positive, right? X minus 5 is positive. If this
Yes,
is
sir.
the case, all right, x is more than 5, we can solve it further. X is more than 5, right?
Yes.
So if x is more than 5, you can replace this whole function as x minus 5. But if x minus 5 is less than 0, this means x is less than 5. Then how to replace this function? With a negative sign, negative of x minus 5. All right.
Okay, sir.
So this you remember. Then we can solve the next question. Write down. Discuss the continuity of the function. Given by f of x equals to mod of x minus 1 plus mod of x minus 2 at x equals to 1 and x equals to 2. All right.
Okay. Sir.
Sir, so we have to solve it for two functions,
Two values. Right.
two values. Yes, sir.
All right, let's see. See, very simple. Again, let's open this modulus function. Right. This will be opened as Sahil. Can you tell me how to open this?
X minus 1 and then x minus 1, it is equal at first. We'll be doing cases, right? When x is
Yes.
equal to 1, okay. Then it is x minus 1 is greater than 0.
So I can write directly x is greater than equals to 1. Right?
Okay, yeah, okay.
And
Got it.
then
And then minus x minus 1,
when x is
then less than 0 and
less
less
than
than 1.
x minus 1 is yes. All right, so this is this. Now x minus. Aman, can you tell me how to open this?
Sir, for you'll get x minus 2 when x is greater than 2. And negative of x minus 2 when x is less than 2.
Absolutely. So we can see directly that this thing is breaking into 2 points, right? 1 and 2. So how to mix this up? This is the main thing to learn here. How to make a single function. So on the number line, if I put 1 and 2, so I can see this 2 points break down the whole number line into 3 intervals, this, and this. Yes or no?
Yes.
So now what we have to do, make a function with 3 intervals. First is when x is less than 1. All right. Second is x is less than 2 but more than 1, this interval. Now the third one is x is more than 2. This thing is clear?
Yes.
All right, Sahel, this is clear?
Yes, sir.
So when x is smaller than 1, less than 1, what functions we have to choose? Look at this. When x is less than 1, which function to choose, this or this?
The first one, sir.
Not first one, the second one. X is less than 1, right?
Yes, sir. Yes.
So minus of x minus 1 plus. How to open this one when x is less than 1? Look at here. This is x is more than 2. This is x is less than 2. And we have x less than 1. So which one to choose, this or this?
Second one.
Second one, right? Why? Because this is x is less than 2 and 1 is obviously less than 2. So minus of x minus 2. All right. Same way here when x is more than 1. So when x is more than 1, this will be opened as this x minus 1 plus, but this is less than 2. So for less than 2, we have to choose this one minus x minus 2. This thing is clear. Sahel, Zaid, this is clear.
Yes.
Yes, sir.
Now when x is more than 2, x is more than 1. So x minus 1 plus x is more than 2, x minus 2. So this is the final function you have to check the continuity for. And but at what values? 1 and 2. So you have to do 2 times. All right. First for 1, find LHL, RHL, f of 1. Then for 2, same thing, LHL, RHL, and f of 2. All right.
Okay, sir.
So please solve it now. I'll give you a few more minutes. This thing is clear, right? This is the main thing to do here. The rest of the question is very simple. Everyone, please give me just 5 minutes, all right? All right, everyone.
Okay, sir.
All right, solve this. Sahel, have you just checked at 1 or 2 also? All right, Zaid. Aman, Sahel, have you solved this?
Yes, sir.
All right, Aman, what about you?
No, sir.
Like you cannot solve or have not
Uh,
solved?
I cannot solve.
Cannot solve. All right. Let's see. So let's rewrite this function in a more simple way. F of x, just open this brackets and we can get this is minus x, so minus 2x plus 1 plus 2, so plus 3, right? And this is minus x plus x cancelling out, minus 1 plus 2, 1. All right, and this is 2x minus 3. So finding the function's continuity at x equals to 1. So first f of 1, when the value of x is 1, we can see the function's value is 1. LHL will be limit x tending to 1 minus f of x. Aman, what will be f of x here? Aman, what will be f of x here?
Sir, minus x minus 1 minus x minus 2.
Right. So you can look at this f of x, right? X is less than 1, so you can simply write minus 2x plus 3, right?
Yes.
Now again put x equals to 1 minus h tending to 0. So limit h tending to 0 minus 2, 1 minus h plus 3. Put h equals to 0, direct substitution, no issues. So minus 2 plus 3 as 1. So RHL, same way we can find very simply 1 plus f of x. So limit x tending to 1 plus means more than 1, just a little bit more. So this is the function 1. This thing is clear, Aman?
Yes, sir.
So this is independent, like constant function. So limit value will be same. So we can see LHL equals to RHL. So limit x tending to 1, f of x is 1, which is equals to f of 1. So continuous at 1. All right.
Yes, sir.
Same thing we can do for 2 also. Now you can solve this, Aman.
Okay, sir. Yes.
All right.
Sir, can you go up a little bit
All right.
because I want to.
Yes,
Okay.
sure. Note it down. No worries. Right. And please, after done, like after noting down, please raise your hands. All right. I'm removing my earphones because there is not a lot of charge in that.
Okay, sir.
All right. So just raise your hands. I'll plug it again. All right. All right, everyone. Next question. I'm audible to everyone, right?
Yes, sir.
All right. Please solve this next question. Very simple question. Determine the value of k for which the following function is continuous at x equals to 3 and f of x is x square minus 9 upon x minus 3 and k, this is x is not equal to 3, x is equal to 3. Here they have reversed the question, right? They have changed the question. What did they change? First they were asking find if the function is continuous. Now they are saying the function is continuous, find the value of k. So what we know, if the function is continuous, then limit at that value must be equals to the function's value, right everyone? Yes or no? So just use this and find the value of k, find the limit value, find f of 3, you'll get the answer. All right?
Yes.
So f of 3 is k, right? Then how?
Yes, f of 3 is k.
Okay.
Try to solve. And here you don't have to find LHL, RHL, you can find the limit directly, right? This function is not broken, less than 3, more than 3. Okay, so you can find limit directly.
So what is a here?
We are finding the limit at 3, right? Like continuity at 3.
Yeah, so for the LHL, I mean, limit x tends to a. So a will be 3 then. So how do you do it? If a equals to
No, you don't have to find LHL, RHL here. See, they have not broken down as less than 3, more than 3. They have just said x is not 3. So what you have to find, limit x tending to 3, x square minus 9 upon x minus 3, right? When x is not 3, this is the function,
no x, okay, x is tending to 3, it is not equal to 3, okay.
right? Whenever we
Okay,
write
got it,
limit,
got it.
all right,
Got it.
try to solve. Solve it, everyone.
No, sir. I can't solve it.
All right, let's see. Very simple limit question. See, we already know f of 3. What is f of 3? F of 3 is k, right? When functions x is 3, the function's value is k. This is clear, everyone?
Yes.
All right. Now we have to find limit. So limit x tending to 3, x square minus 9 upon x minus 3. So if you use direct substitution, putting 3, so we get 9 minus 9, 0, upon 3 minus 3, 0. So if you cannot use direct substitution, what is the second step? Factorization. Remember limits when we did limits, everyone? Yes.
Yes.
All right, Zaid. Sahel, this is clear.
Yes, sir.
So factorization, how we can use factorization? So limit x tending to 3, this is x minus 3, x plus 3. Yes or no, Aman?
Yes, sir.
So this is cancelled. Now again you can use direct substitution. So we get limit x tending to 3, x plus 3. Use direct substitution. So 3 plus 3 is 6. If the function is continuous, then f of 3 must be equal to limit x tending to 3 f of x. Right or not? Yes or no, Aman, Sahel, Zaid?
Yes.
Yes, sir.
So k must be equal to this value is 6. So value of k is 6. So simple. All right.
Yes.
Okay, sir.
Please note it down, everyone. Done.
Yes, sir.
All right. All right, Zaid. I'll talk to the team. We'll make a group. All right. Solve this question. Find the value of lambda so that the function given below is continuous at x equals to minus 1. All right. So f of x equals to x square minus 2x minus 3 upon x plus 1 when x is not equals to minus 1, and lambda when x equals to minus 1. Similar question. I'll give you a few minutes. All right, sir. Aman, have you solved this?
Yes, sir.
All right. Let's see how to solve this one. Again, f of 1 is lambda and limit extending to 1 x square minus 2x minus 3 upon x plus 1. This again factorization. So limit extending to 1 x square minus 3x plus x minus 3 upon x plus 1. So this is limit extended to 1 x common x minus 3 plus 1 common x minus 3 upon x plus 1. So limit, this is minus 1, right? Extending to minus 1. X plus 1 x minus 3 upon x plus 1. This is cancelled. Direct substitution, the value is minus 4. So lambda you can easily get minus 4. Everyone is correct?
Yes, sir. We got the same answer.
All right, Sahel?
Yes, sir.
Zaid? Yes, sir.
Yes.
Zaid sent me the answer. All right. So write down a homework question. If the function f of x given by f of x equals to 3ax plus b if x is more than 1, 11 if x is equals to 1, 5ax minus 2b when x is less than 1. Is continuous at x equals to 1. Find the value of a and b. All right.
Okay, sir.
All right then. So note it down. Tell me when you have done.
Sorry.
So that's 11, right?
Done, everyone?
So that on the second line, is it 11 under
Yes.
3x plus? Okay. Done, sir.
All right. So this is all for today's class. All right. I hope everything is clear.
Yes, sir.
Everything regarding continuity. All right. So you can solve NCERT questions also. All right. You can ask me if you have any doubts, and you will be getting an assignment also on this. So please complete all of that by next class.